We are into the second phase of our C programming language curriculum. First phase was control structure of C language, and in the second phase, we have studied functions in C. Basically, today I'm going to start pointers in C, which is one of the most important topic of whole C language, or you can say C language, C++ language. One of the most important. It is not, or it cannot be considered as a separate topic, but it will be a part of each topic today onwards. As an individual concept, I am going to cover it in a single topic, but pointer will reappear in each chapter onwards. So pointers and arrays, pointers and strings, pointers and structures, pointers and file handling, okay, pointers and dynamic memory allocation. So everywhere you have to face the pointer. Basically, concept is very small. In fact, it can be defined in a single statement. So as far as definition is concerned, very small definition. But there are, it is said that students are afraid of C language only because they are afraid of pointers. Partially it is true. Partially. To some extent it is true. The fact is that without pointer machine cannot work. Though there are not pointers in Java language or Python language because of which the languages are very popular. But the fact is that pointers have been used by these language developers, but not at the programmer level, but at the machine level. That is the only difference. Because there is no escape from the pointers as such. So what is basically that? Which important terms we are going to discuss in this chapter? First of all, memory. Memory we have used, the word memory we have used many times in the past since the first chapter, right? So there is two types of memory. One is a primary memory, another is the secondary memory. Secondary memory is in the form of hard disk, which is a permanent memory. Primary memory is in the form of RAM, random access memory, which is a temporary memory. This RAM or a temporary memory is also called as a main memory. Now, when we talk about the memory, we have to talk about the address. If you can, if you can recall, when you use the scanf function, and if you want to store address, or if you want to store a number entered by the user in the variable, suppose x is integer, you want to store a value inside x. Then we do not write x as an argument in the scanf function, but I have told you to write ampersand x or ampersand y. So we are passing. What is that ampersand operator? It is an address of operator, unary operator, address of operator. So you are telling the machine, the operating system, the compiler that the number entered by the user, store it where? At the address of x. That's why we write ampersand x, right? So as far as address of a variable is concerned, we have already used that, but unknowingly we have used that. Now we will use it, use that address explicitly. Okay. So each memory has got address. Each memory. Likewise, in this world, each location has got a unique address. Okay. There can be similar homes, similar people, look-alike people, look-alike cars. Everything can be similar in this world, but address cannot be same. Address is different of each location in this world. Similarly, address of a particular memory is unique, and that the same concept have been used to design the pointer. So there is a variable Variable occupies the memory and variable has got the address. Okay, three simple terms. We have seen data types, just I discussed, right? So data types have been categorized as primary data types and secondary data types, right? Primary data types are also called as the primitive data types. These are also called as built-in data type, and each language has got its own set of built-in data type. Okay, so integer, character, float, these are built-in data types of language. Double, right? These are built-in data types. Each language has got its own set of built-in data types. But built-in data types are not sufficient for solving any problem. Each time it is not possible. Each time you cannot store variable. I mean, each time you cannot store data in integer variable or a float variable. Some other kind of data might be there. Like suppose if you want to store name of a person, then as of now you cannot use integer, you cannot use the character, you cannot use the float, you cannot use the double. Okay, so these built-in data types are not sufficient to store name of a person, address of a person, right? So this you cannot store. So each language, okay, as of now forget about other languages. Let's talk about the C language. Dennis has given you another kind of a category which is called as the secondary data type or secondary constants. So these are the constants. These are called secondary only because of two reasons. These are not built in, and second reason is that these have been derived from the primary constants. These have been derived from the primary constant. That's why these are called secondary. These are also called as derived. Why? Because these are derived from the primary constant. So there are a few secondary constants, like pointer is one of them. So today we will be discussing first secondary constant, right? First in our list. So there will be a pointer, then there will be an array. Array is a secondary constant. There is a string that is also a secondary constant. There is a structure that is a secondary constant. There is a union that is also a secondary constant. So number of secondary constants are there. We are going to discuss all of them. So first in our list is a pointer. So pointer is a derived data type or a secondary data type, right? So that is something about the terms we are going to use in this topic. So these are basically some terms which are used in the industry or while learning programming language, or in the books you will find these kind of terms. So you a term like a referencing or a dereferencing, right? And couple of operators like address operator and indirection operator. So these two operators we will see today in this chapter, and I will discuss about what is that referencing and dereferencing. And since just we have finished the function chapter, we will try to understand the importance of the pointers with the help of functions, so that our concept about the pointers are strengthened. Okay? It is not that once this chapter is over, pointer is a history. No, pointers will appear in each chapter. Almost you can say in on each day, I will refer to the pointer. Right. So this is just a few slides. Directly we will go to the programming. And once I teach the basics of pointers, these are basically very small topic, but it will not It will always be there in your life. Okay, till you are going to learn C language, C++, Java, Python, or any language. Okay? They will always follow you like a shadow. Hmm? I will take very simple and silly looking program. I think I feel prima facie you will feel that why I am taking so silly programs. Okay, so silly and so small and nonsense programs. But let it be. You cannot learn pointers without that, right? So demonstration of pointer in C. Right? I declare one variable index. Right? What kind of data type it is? It is a primary data type. Right? I will store for you in that. This is called for you is stored in X. Now let's try to print something. So X is equal to percentage. We write here X. So what will happen? Contents of X will be printed. Right? What will happen if I try to print? If I want to know the address of X, because X has been given some memory, right? X has been given some memory. As we have seen, X has been given 4 bytes of memory. How we come to know that? Suppose I write number of bytes reserved for X percentage. So how we can find that? There is a one operator called size of, right? What is the size of? That is kind of a function. So if you write suppose size of X, it will give you how many bytes have been given inside the memory. Right? I run this program and compile this. So 5 has been stored in X. And what is the number of bytes? Number of bytes reserved for X is 4. Right? So 4 bytes of memory has been given. But what is the address of that? Because X takes some memory inside that data segment. Okay, some memory is there. So what is the address of that? Till now we were sending that we were using that ampersand operator for the scanf function. First time we will use that for printing the address because ampersand is the address operator, right? Address of operator. So address of X is percent. Basically, address is always positive. Address cannot be negative because address system starts from 0. Likewise, no roll number in any class starts from 1, 2, 3, 4, 5, something like that. Have you seen roll number like -1 to 5? No, roll numbers are never like that. Similarly, address mechanism on the memory always start from the 0 onwards. Okay, there is a I have explained you and you have watched that first chapter. I hope so. So when you write the C program, one data segment and one code segment is given. Data segment is used for storing variables you have declared in the main function, right? So on that data segment, first byte has got address as 0, second byte has got address as 1, 3, 4, 5, 7, 8, 9, 10, like this, right? So on that 1, 2, 3, 4, 5, okay, huge memory is given. We want to find what is the address of X because address is given by the operating system. We cannot give address. We cannot say that, okay, for this X, I want to store at this address. Programmer doesn't have that right. Programmer cannot do that. Rather, nobody in this world can do that. Allocation of memory is given to the that responsibility is given to the operating system, right? But at least we can see what is the at what address that X has been stored. So since address is always positive, we do not use usually we do not use percent %d as a format specifier because percent %d format specifier for is for integer. When I say integer, it is a signed integer, right? So it can be negative or a positive. But address cannot be a signed integer. It is unsigned integer, right? Always is always positive. So we prefer to use format specifier as a U. U stands for signed, right? If you use the percent %d, it may work, it may not work, but percent %u, it will always work, right? So percent %u, and I not rate X because X contents of X. I have written here. When I print X, I print contents of X. But I want to print address of X. So I will write address of X. So this will print address of X. Right? Listen everything carefully. The seemingly so simple things will become complex just within next 15 minutes if you do not listen it very carefully. Okay? And even though you listen it carefully, it is going to be confusion. Okay. So prepare for the war, right? Okay. So if I now compile the program, X is that file is stored, number of bytes reserved for X is 4, and address of X is 642268, something like that. If you run this program on your machine, address will be different because that operating system will not decide which memory is to be given. That is random, absolutely. Okay. So even tomorrow, if I execute this program, some address will be different, right? So as of now, this moment for this program, for current execution, address is 642268. If I run it again, it might be different, or it might be same. There is no guarantee. Nobody can give you guarantee that again same address will be given. Okay. Now it is same, but no problem. Now, if I declare one variable as a float variable, right? Again, this is a primitive, right? Now I will store some value in the variable because it is a float. So 5.6 is stored in the variable y, right? Now I will perform all same operations for the variable y. I'll write y is equal to y. Cannot write percent d here, but percent f. Right? Number of bytes reserved for y. Number of bytes, it is going to be percent d. This cannot be because number of bytes is always a positive integer. And size of I have to write y. Right? Address of y. We will try to print what memory is given to the y. And y here. And this will be address of y. Right? So I will compile this program again and run this program. Okay. So x is 5. The same address I think. 642268. Right? Number of bytes 4. Now this is y. Contents are printed. Number of results for y. Again 4 bytes is reserved. And address of y is okay. This 68. Okay. This is 64. So previous 4 bytes have been given. Right? Previous 4 bytes. So 64 is the starting location. So 64 to 65, 1 byte. 65 to 67, 66, second byte. 66 to 67, third byte. And 67 to 68, fourth byte. Right? 4 bytes have been given for the y. I will declare another variable. Right? This is also primitive. Right? Let me store something here. We'll copy paste this so that typing is some time can be saved. I'll write here C. What is that? What variable I have declared? CH. CH. Okay. I'll assign some value character constant. Suppose T. I have stored as a T. Let me store C language. That is a C. Okay. So here C is stored in CH. Right. Let me print that. Format specifier should be %C and the argument name should be CH. Number of bytes reserved for CH. Okay. And you have to write CH. Right. Address of CH is %U. It has to be. And here CH. And this will be address of CH. Right. So all necessary changes have been made. So X, Y, and CH. One is integer, another is the float, and third is character. So it is 68, there is no problem. It is 64, no problem. Address have been given same. And this is again previous byte, 63. Okay. And number of bytes reserved for CH is 1. Okay. So character constant is taken. Float constant is going to take 4 bytes. Integer constants 4 bytes. Right? Fine. Now, now, Dennis Ritchie thought, can we think of storing an address of a variable in another variable? Understood? Storing an address of a variable in another variable. Yes, Dennis said yes, you can do that. But how to do that? Right? How to do that? Because it is an address. Okay. So the integer variable cannot take address, right? Because integer can be positive as well as negative. Right? Float cannot take address. Character cannot take address. So Dennis Ritchie said, okay, wait, I will give you one more data type, which is a derived data type, which is called as a pointer, right? So, how to declare the pointer? If you want to store, listen carefully. If you want to store address of a integer variable, then you have to store it in an integer pointer variable. That we call it as a pointer. So what? How to define the pointer? Pointer is a variable which can accommodate address of another variable. That is a pointer. Pointer is a variable which can contain an address of another variable. That is a pointer. So how to declare that? He said that just attach the star asterisk to the name of the variable. It will be recognized. It will be a pointer variable. Okay. If I want to store, listen carefully. If I want to store address of a integer variable, then I should have integer pointer. If I want to store address of a float variable, I should have float pointer. If I want to store address of a character variable, I should have a character pointer. As simple as it is, a single line definition. Okay. So if I want to store an address of x, which is an integer, I should declare a pointer as an integer pointer. So this is a pointer declaration, right? But these and these are same, no? So how compiler will count that? Only because you have written the PTR. Because PTR is just name. It can be P as well. So what did the Dennis Ritchie say? Attach the star to the name of the variable in the declaration. So attach the star, right? This is a pointer variable. Okay, pointer of type int. Why? Because it is integer pointer. Integer pointer, right? Now this x is integer. It means x can store integer. Y is a float. So we say that y is capable of storing floating point value or a real number. CH is a character. Why? Because CH is capable of storing character constant. So PTR is a variable which can store not integer but integer and star. So integer pointer. So PTR is a variable which can store an address of integer variable, right? This can be written in three ways, like this, or like this. All three are same. So that star you can attach to the int. Okay, just after int you can write. It can be written like this: int star ptr, or it can be int star ptr. One and the same thing, right? So how we can rate this ptr in a simple terms? Ptr is an integer pointer. That's it. In a technical word, some complex no way, it can be read as PTR is a variable which can contain an address of a integer variable, right? An address of a integer, another. It should be another. So here, let's try. You might be having a lot of questions. Why to do this? What is the use of that? This is not the time. Okay. As we go on progressing, you will come to know without pointer, life is not there. Okay. Pointer is as good as no oxygen. Okay. Without oxygen, can we live? No. So without pointer, C cannot live. The other machine cannot work. Okay. So it is as important as it is. So this is the integer pointer, right? So let's try how to PTR. How we have defined PTR is a variable which can contain an address of another integer variable. So let me write PTR is equal to, I store the address of X. That's it. Whatever it has been, the reason it has been created, we have written the same fashion. Okay. PTR is a variable which can contain an address of another variable. So we have stored an address of X. So what is the now? What is the meaning of this statement? Multiple meanings are not multiple. It can be written in multiple ways. First, it can be said that address of X is stored in PTR, right? Another way we can say that PTR is a pointer to X. Why? Because PTR contains an address of X. That's why PTR is pointing to X, right? Third statement, PTR refers to X, referring to the X, right? PTR refers to X. PTR is a pointer to X, or address of X is stored in PTR. Now, what is the use of this? Not exactly use of this. What operations we can perform? I will write four statements. I don't know, three or four statements. Okay. Contents of PTR. What does that PTR contain? Now PTR contains an address of X. So it is address. So we will use the format specifier as percent. Okay. Now I will write over the straight away as PTR. Right. I will write printf contents of X. So contents of X. X is an integer variable. We will use the format specifier as percent. But earlier we accessed the contents of X using variable X. But since we now have stored the address of X in integer pointer PTR, and we have said that address of X is stored in PTR. Second statement is PTR is a pointer to X. Okay? So PTR is pointing towards X. Huh? So we will try to access contents of X using PTR variable. So I will write star PTR. Star PTR. This is called, I use the word indirection operator. This is an indirection operator. It is also called as a dereferencing. This is a reference and dereference. So star here is called as a dereferencing. Okay. And third statement I will write address of PTR, because PTR is also going to take some memory. Right. So I will have to write percent %u. And how to print the address of PTR? Ampersand PTR, that's it. Like carefully observe these three statements. Okay. Actually, concept is very simple. So what is important for this our is put some slash in here. This contents of PTR. Okay. If you correlate along with this, address of X and contents of PTR are same. That means address of X has been stored in the variable PTR. Okay. But using that PTR, if you attach the star operator, it will access the contents of X. So you are printing contents of X remotely. Remotely you are trying to access. Right? Remotely, without using variable name of variable X, you can access contents of X. Okay, remotely, because PTR is different, X is different. You have stored address of X in the PTR. You attach the star to the name of the variable, it will give you contents of X. And address of PTR, again address of PTR will be different. So this is 56. Okay. So address of X is 68. This is 64. This is 63. And this is something different, 56. 642256. So PTR is stored somewhere. Now if you are of insane mind, crooked mind, not crooked exactly, I can say curious mind. You should ask me. And I definitely know. I know. I'm quite sure about you. Both of you will ask me question. So if PTR is given separate memory, can we store address of PTR in another variable? Yes, you can do that. You can do that. Again, that variable is going to take separate memory. Can I that again store that address in some another variable? Yes, you can do that. How many times you can do that? Multiple times. Okay. So this operation is very simple, but it is very effective and you can do anything. Basically, this is a pointer. That's it. Isn't it the smallest chapter? Yes, it is the smallest chapter. But it is the hardest and nightmare of C programmer. Okay? Though the concept is very small. This is the concept. This is end of the story. This is end of topic. As far as pointer is concerned. Concept of pointer is concerned, this is over. Nothing is left. Okay? Fine. So we will do rest of the things. Okay? If I want to store address of y, I will declare another variable like suppose fptr float pointer, right? Char ptr, cptr, right? Character pointer, right? Now, how we can do this? Same ptr, fptr is equal to ampersand y and cptr is equal to ampersand ch. That's it, right? So same statements I can write here. Same statements I can write here, right? Contents of fptr, 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 contents of y has to be f, address of APTR will be having separate address, right? Then contents of CPTR, this will be contents of CH, it will be %C, this is a star CPTR, address of CPTR, address of CPTR. So just observe this. If you write the same program, I will share this program along with you. You will get different addresses. That's it. Okay. So contents of PTR 68, same, right? For unit. Contents of FPTR. See here. This is the address of Y. 6464. Address of Y. And using that pointer, you are accessing contents of Y. Same here. Address of FPTR. It is taking separate memory. Right? This is previous to the PTR, but there is no relation. This can be anything. Okay. Address can be anything. Okay. Contents of CPTR and address of CPTR. This 48. Right? So address, since it is unsigned, it is going to take 4 bytes. Be it integer pointer or character pointer or float pointer. It is going to take 4 bytes. Character will take 1 byte. That is different story for storing character. But when you store address of that character variable in another character pointer, then that pointer is going to take 4 bytes of memory. Why? Because that pointer is an unsigned integer, right? So it will take 4 bytes of memory. So this is all about a pointer.